No, you're not on video. It's just my voice in the screen. I know. So, just to review here, my domain here, I set what's under the radical greater than or equal to 0, because it can be 0. Solve for x and then translate that to interval notation. Here, I set the bottom, say it cannot equal 0. Find those values where it cannot, the values it cannot be, otherwise it will equal 0, and then break it into your interval notation. So there it is. Next one, number 3, it says graph to find the real solutions. Are we okay on that one? Did you get that one? What do we do first? Move everything over. So what we're actually graphing is we're actually graphing that. And so you go type it into your graphing calculator. I would start with Zoom, Z standard, just most of these that'll work, and then find your zeros. So are we okay on that one? And then this one, number 4, technological quirk. What do you have to do before you remember? Square it. Square each side. Then graph that, which is x cubed minus x squared minus 44x plus 84 equals 0. It's just a technological quirk on the TI calculator, so you have to square it. If there's a radical, more than one radical on one side, you have to move one of them over, then square it, then move everything over, graph it. Then you can see where it would have crossed had it shown that, and then find those. So are we okay with the zeros? So there will be some of those on the test. All right, determine if the equation has any symmetry. Now, first period they asked me, do I have to know even, odd versus symmetry? Yes, you do, because on the multiple choice I might have as options even and odd rather than y-axis symmetry and origin symmetry, so you need to know those. But otherwise, I would, if I ask what's the symmetry, you can just show me. What do you think here on number 5? We're looking at, I have an x squared top and an x squared bottom. It is y-axis symmetric. How do you know? If I ask you to prove it.
X is negative, so
Yes, if I plug in negative x for x, it will not change anything. And so when I square each of these, it will return right back to what it was. And so this is y-axis symmetry. Remember, if you plug in negative x for x and get the same thing, it's y-axis symmetric. If you plug in negative y for y and get the same thing, it's x-axis symmetric. What about here? Y equals 2x over x. If I plug in a negative x, it's going to stay positive on the bottom, but then become negative on the top. If I plug in a negative y, it's just on that left-hand side. It's going to change the sign of the whole thing. What happens if I plug in a positive and negative y?
wait, why there's 2 negatives?
So we'd have a negative y equals 2 times negative x over absolute value of negative x. So here, this is going to become positive. So we have y equals 2x over x. So it's looking like origin. If you know, what's that? How did you?
Nice.
So how else could you check these, though? You could graph them if you're allowed to do that. So you could be allowed to do that. If you graph this one, did anybody graph it? See what it looks like?
I think I did. Did you?
I mean, it wouldn't hurt to graph it. 2x over just to see what it looks like, because it's kind of a funny looking function. You probably have never seen this one before, huh? Let's see what 2x over absolute value of x looks like. So,
Oh yeah, it's definitely more.
so when we graph it,
It's a line stops at the x and it moves up.
yeah, divided by,
It's really weird.
it's under math, just to remind you, absolute value, you're going to see that in there. And this, I'm in classic mode, that's what it looks like. And then I like to hit zoom, Z standard, and we have kind of what's called a salt and pepper type thing. So when x is less than 0, it's -2, and x is greater than 0, it's 2. So what makes origin symmetric, remember, is a flip over the x and then a flip over the y, and that's what's happening here. Okay. So visually we can see that.
I like that.
Kind of fun graph, huh? It's a piecewise function. It's 2 pieces. So this is origin symmetric. All right, find the average rate of change from -2 to 1. Okay, so average rate of change is just slope. We've just got to find g of 1 minus g of -2. That's kind of like your y2 minus y1 over 1 minus -2. Do you know how to calculate g of 1 and g of -2? Plug it in, yeah. So g of 1 would be 3 minus 2 is 1, plus 3 is 4. And then g of -2, that's going to be 412 plus 4 is 16 plus 3, I'm getting 19. 1 minus a -2 is 3, so I have -15 over 3, which is -5. So that's my average rate of change. So you get your y2 and y1 by plugging in the values that I give you into the function. Okay. Graph the following. I'm going to have to factor out a negative here first. It's 2 times the square root of negative and then x plus 2. Because I need to have this in the form where it's either f of something, f of x, okay, just positive x, or f of negative x, where there's just a sign in front of the x. But this is separated out. I'm trying to get it into a specific form. So if you see under the square root sign, a negative, or within the absolute value, a negative in front of the x, you're going to have to factor that out first and regroup it. So this tells me that if I have a parent graph that looks like this, approximately, that you're going to have to memorize your parent graphs for this test. Whole yellow sheet. If I reflect first, which is what I suggested, reflect first, I'd have this. It's a reflection over y. And then there's a stretch of 2 units. Okay, so it's going to make this taller. And then I'm going to shift it 2 units left. So go 1, 2 units left, and then draw that guy here. So it's that last drawing there. I could take out all this other stuff. Okay, there's the parent graph. There's my stretch. And there's my, that was my reflection. So there's my final answer. I have 2 to the left. I've flipped the parent graph over the y-axis, and then I've stretched it up a bit, and I drew it it was a quick drawing of it. I could have plugged in maybe a value or two. If I plugged in, say, for example, -3 here, -3 plus 2 is -1 times negative is +1. Square root of 1 is 2, so at -3 I should be at about 2. I hit it with my rough draft there. All right. What about b here? We've got absolute value function, so v. There's no reflection. There is a vertical compression or squishing down. It's going to make it open up wider and squishes it this way. So I'm going to wait to do that, but it's going to take the absolute value function, which looks like this. It is going to squish it down, and it's going to move it 3 left and 2 down. So if I go 1, 2, 3 left and 2 down, there's my new vertex. If you want to see a more accurate graph, just try doing a table. Go x, y, and try a couple values in. What if I plugged in, let's see what it looks like at 0. In 0, 0 plus 3 is 3, half of 3 is 1.5, 1.5 minus 2 is -1/2, so at 0 it's about -1/2. What about at 1, 2, 3, 4, -5? If I try -5 in there, -5 plus 3 is -2. Absolute value of -2 is +2. Half of 2 is 1. 1 minus 2 is -1. So this one was -1/2, and this one was -1, I believe. It's going like this. It gives you an idea of what it looks like as it's compressed by half. So that second drawing is your graph of the absolute value function. All right. Number 9, piecewise function. Okay, the graph of the first one is a line, right? And the graph of the second one is a parabola. Here's the endpoint. We have an open circle at x equals 1. Or if we plug 1 into this equation, what do I get? Yes, so at 1, -4, I have an open circle. Now, using our knowledge of linear functions, we can only graph this direction from this circle. Okay, we're only graphing this direction. So it says I have a slope of -1. From this point, let's do a slope of -1. We would go left 1, up 1, and left 1, up 1, left 1, up 1, and it would keep going like that. Look at this. What's the y-intercept according to this top equation?
Wow.
-3, and so that's right where I went through. All I need is a point and a slope to graph the line, and I need to know which direction to go. So graph the endpoint, and then go in the correct direction. Okay. Here we have x is greater than or equal to 1. If I plug in 1 for x, 1 squared equals 1. So I'm at 1, 1, and that is the starting point for the rest of my parabola to the right in this direction. I know x squared is a parabola, so if I just graph maybe one other point like 2, 2 squared would be 4. So at 2 I'm at 4, and that's what that thing looks like. So it just keeps on going. So there's my piecewise defined function. Okay, number 10. It says express in interval notation. I think probably most of you factored first, right? So it's x minus 10 and x plus 4, okay. It equals 0, so x equals 10 or -4. Draw your number line. Here's -4 over here. Here's 10 over here. And so it breaks that number line into 3 segments. You could test points. You could try -5 in here and see if it's true. Or you could test maybe 0 from here and see if it's true. Or you could test 11. But if we really understand what we're being asked, it's take this function. What does this function look like? A parabola. It comes right on through and right on back up. I know that. Okay, I know that it's facing upward because the coefficient of x squared is positive. I know this is a parabola, and this symbol right here is asking me where is the parabola greater than 0, or in other words, where is the parabola above the x-axis? And so I see it happening to the left of -4. It's above the x-axis. So in interval notation, it's -∞ to -4, and then also from 10 to infinity, it is also above the x-axis, and that's it. If I change this to less than 0, then I would have as a solution -4 to 10. If I change this to greater than or equal to or less than or equal to, it would just change what the ends look like here. I would have closed brackets, and that's it. Those are the 4 cases for solving a quadratic inequality. Okay. On number 11, you have to find the max and min using your calculator. We did that today. Okay, once you find the max and min, what'd you get for a max? Okay, so are you guys okay with finding the max and min on your calculator?
Yeah, that's all I know.
Okay. Okay. So the max is at -0.523. And then the min is x equals 3.18. So I have my max and my min, and I can find my point of inflection right off the bat just by taking the average of those two. So x equals, it'll be,
What's the average of this?
yeah, -0.523 plus 3.189 divided by 2, and I get 1.333 is the point of inflection. Here's the inflection. So you can find all those just right off the bat. So Then the intervals on which the graph is increasing or decreasing are always broken up by the maxes and mins. Yeah.
Would you always use the denominator?
Yep, because that's what it means. The average, you're going to add them up.
Oh,
Divide by 2. Yeah. And that'll give us a good enough estimate. We're already estimating the max and min on the calculator, and then we're just finding halfway in between them. That's good enough for now. That's how we do it algebraically, get an estimate of it. So increasing, decreasing intervals, you got to figure that coming to the left of the max, it's got to be going up, right? It's going to reach a max point, so it's got to be coming up to the max, and then it goes back down to the next minimum, and then it goes up from there. So that's what's happening. So the increasing interval would be negative infinity, comma, negative 0.523, union, so that covers from here up to here, and then it's going to increase again here. So from the minimum, which is at 3.189, to infinity, it's also increasing. And then it's decreasing in between those two, from negative 0.523 to 3.189. That's where it's increasing.
So the increasing, you're just saying, like, where? I don't know why I didn't understand that. So it's this whole
Increasing is where the function's going up,
yeah,
and
okay.
decreasing is where it's going down because it goes from left to right. All right, and then the average value, average rate of change, like the other one I asked you about average rate of change, I gave you a function. This one I gave you a picture. So if I want the average rate of change from hour 2 to hour 12, I just have to find a coordinate for hour 2. So it looks like that's the coordinate 2, comma 50. And then the coordinate for hour 12 looks like, yeah, and 12, comma 80, and then just find the slope between those 2 points. So 80 minus 50 over 12 minus 2. So that's 30 over 10, right? 30 over 10, which is 3. So that's just giving me the slope of this line from here to here. And then you could do the same thing for the other two.
I understood that one, and the next one was the one that we did in class where
Yeah.
I had no idea what I was doing.
So we have f of x plus h minus f of x over h is the difference quotient, which you need to memorize. So you have to know that. And then now we need to translate what that means. The f of x plus h term says, okay, take x plus h and plug it in everywhere you see an x in the function that's defined there. So I have x plus h cubed minus 3 times x plus h. That's just the f of x plus h term. Then I have minus, that's this minus sign right here that I'm now applying, f of x. Well, f of x is just x cubed minus 3x. I'm substituting it in. Or you could think of it as I'm just plugging in x for x, which gives me the same function I started with, all over h. So this one is quite a bit of work. This is the one where we have to expand out the x plus h to the third, maybe using the appropriate row of Pascal's triangle. And the appropriate row of Pascal's triangle gives us this coefficient 1 x to the third plus 3x squared h to the first plus another 3xh squared plus h to the third, and that's just this expanded out. Then I distribute the 3 minus 3x minus 3h, and then I distribute this minus sign here to each of these, which is minus x cubed plus 3x. And that's all over h. All over h. And if I've given you something that actually would have a derivative to it, as we call it in calculus, then you should be able to simplify out all of the the x terms. So in other words, you'll be left with just terms that have an h in it, and then one of those h's will cancel with the h on the bottom. So 3x is gone, x cubed is gone, and so I just have these 1, 2, 3, 4 terms that all have an h in it. So what we do is we cancel an h out of each one of those, bringing down the power by 1.
And it's going to be like that in the test.
Yeah. So you'll have, as your final solution here, I'll just write it down here underneath 14, it's 3x squared, that h is now gone, plus 3x, one of those h's is gone, plus one of those h's is gone, so it's now h squared minus 3 because the h cancels. And that's your final answer for number 13. The key really is just this first step, and then lots of fun algebra follows, and hopefully make no mistakes. But what you'll find is that these, on the ones I give you, these terms will cancel out if you've done the algebra correctly, and you'll be able to cancel 8.
That's how I know if we did it wrong.
Yeah, at least for the ones that I'm going to give you now. Yeah.
Okay.
And then 14, given the point 4, negative 1 is on the graph of fx. So I just graph it. 1, 2, 3, 4. Negative 1 is right here. That's 4, negative 1. Find the new point if you apply these transformations to it. So the negative sign is going to take 4, negative 1 and flip it over the x-axis, bringing it up to 4, positive 1. Let's extend this a bit, because the x minus 3 is going to take, after you reflect it over x, take that point and shift it 3 units right. So my new point is at 7, 1. So that's it.
That one looks so complicated, and that's like so many to do that, and I don't do it.
Yeah. That's it.
Okay, so we just have to memorize the formulas, like the F